Okay, so this is going to talk about section 7.2, which is going to be circles and ellipses. And again, just like we had with parabolas, we have a specific form for ellipses that we're going to look at. So we're going to look at the expressions and then try to figure out which way the graph is going to go based on the characteristics of an ellipse. So for an ellipse, we're going to have a set of foci. We have a major axis and a minor axis. We have our vertices, and then we have our eccentricity. All right. Um, so when we're looking at an ellipse, this is our kind of standard form that we need to be aware of. Ellipse can have a major axis along that is horizontal to the x-axis, and that's going to be stretched out horizontally. It could also have a major axis that is this point, this way, vertically, that's going to be stretched out vertically. What we can see are the two focal points. So we have two focal points, or the foci, which are along the major axis. And the way that an ellipse is going to work is that we have this distance. We can imagine a string that's attached to our two focal points. And if we were to take that distance, that same distance, and stretch it all around, what we would actually sketch out would be the ellipse. So those distances are going to be the same. All right, so we have a standard form of our ellipse. So we can see that for this one, we have an x squared term where a is always going to be our major axis, so a is the bigger value. So when it's going left or right, so stretched left, right, a is attached to the x. When it's going up or down, a is attached to y. It is always equal to 1 on both sides. Our center point is the same with our transformation, so k is our center point. What's attached to x is the h value. What's attached to y is the k value. What will switch here are a and b. We also have another relationship here that's going to allow us to figure out this value of c. All right, so the value of c is going to allow us to find where those focal points are. So if I take my value of the center point and I add or subtract c, that gets me to where the focal points are. If it's going up or down, I take my k value, right? So that is the y coordinate, right, that's attached there, and I add c to both or subtract it to get the focal points for an ellipse that has a major axis that's vertical. So we're going to keep that in mind as we look through this. This looks like the Pythagorean theorem of a squared plus b squared is c squared. It's not, right? We have a subtraction in between them. So a squared minus b squared. All right, so see how those work as we look through some examples. All right, here's a short animation that kind of walks through what an ellipse will look like in terms of if we manipulate those values. So we can see in this case, if I make the radius bigger, this is a circle. We'll get to that at the end. If I change A, right, if I make that major axis along that point, I see it stretches out horizontally. If I make B my larger value, then it stretches out vertically. And then my center point, my focal points, if it's stretched out here, would be along this major axis, that horizontal line that we have going there. All right. So if we go back to this, we have our first example is to graph this on ellipse. All right, we can tell that it's an ellipse because I have two squared terms, it equals 1, and I have addition that is linking them together. First thing I want to note is where my center point is, so the thing that's subtracted from x, the thing that's subtracted from y. I then want to figure out what my major axis is. That's going to be my bigger number down here. So this is my a squared term. This is my b squared term. And from there, we can figure out a is 3, b is 2, and we can calculate c, and that's going to tell us where our focal points are going to be. So as we move through it, we can fill in our table to figure out the center point. All right, so the center point comes from h and k. The foci are plus or minus the c value. The vertices are at the edge. And then we have our major axis and our minor axis in terms of where those values lie. So that's just using the standard form of an ellipse to move through it. If we want to sketch the graph, we can use a table of values, but what we'll more often do is get our center point, right? Figure out where our major, what's our major axis, that gives us those vertices that way, and then we have, so our major axis is this way, and then we get those vertices on the sides and the vertices on the top using the minor axis. All right, here's one that's not so apparent because we are not given it in standard form. So we do notice that we have an x squared term and a y squared term, so it's not going to be a parabola. What we're going to do is we're going to grab the x terms and the y terms and complete the square so that we can get this into our standard form of an ellipse. So we're going to take it in standard form. There's our original equation. All right, we're going to group the x terms and the y terms, and then if we need to divide anything out, we can. That'll make completing the square easier. So I can see that 4 will come out of both of those. So they factor out a 4, and then this one. And now to complete the square, we take half of this value, which is 3, and square it, half of this value, which is 5, and square it. So we add 3 squared, which is 9, 5 squared, which is 25. What we need to do, again, is add that to the other side. Now be a little bit careful. We can see we added 9 in here, but since it's multiplied by 4, we've really added 36. So we need to put a 36 on the other side. After we've done that, we're getting closer. What we see is that we are getting closer to our standard form. This needs to be a 1 though. To get this 64 to be a 1, we divide by 64. And then this is our standard form of an ellipse. Now we can see this is our larger term. So this is going to be our a squared term. This is our b squared term. With a squared and b squared, we can figure out c, which is going to get us to our focal points. All right. Calculate c, and then from there, basically, we can start to sketch our graph. We have our center, we have our focal points, and then we know our major axis is going to be 8, our minor axis is going to be 4, and that's going to allow us to sketch where those vertices are on the ellipse. They use a table of values to put those points out there. For us, we can graph. We don't need to make a table, but this becomes our ellipse. All right, as we move forward. All right, so again, figuring out the center point, figuring out the major and minor axis, and then figuring out when we apply that to the center point, what it looks like. All right, so you need to try this one. You're going to go ahead and pause the video in a second. And then you're going to group your like terms. So get your x's together, get your y's together, factor out anything that you can. It'll make life simpler. And then complete the square, making sure to add things to both sides. Once it's in standard form, identify h and k, identify a and b, and then from there you can start to sketch what your ellipse looks like. All right, here's another example where we haven't been given an equation, but we've given some properties of the ellipse. And from there, what we want to be able to do is to sketch what the equation looks like. So what we know is if we were to look at this and say that we have a major axis, so we have a graph. So I'm going to put in a graph. And I know that at 5, -2 is my major axis. So 1, 2, 3, 4, 5. 1, 2, there's 1 point, and then -1, -2, -1, -2. So that is my major axis, which means that is my center point, my ellipse is going to be in the middle of that, and then half of that is going to be A. So I have that value there for A. I know that my minor axis goes from 2, 0, so 2, 0, which is right there, and then goes down to 2, -4, which is going to be down there somewhere. That value, that's my minor axis. Half of that is going to be B. So I can figure out just using geometry and the coordinate plane what A and B are going to be and where my center point is going to be. And so from there, what we can do is once we know A and B and the center point, we basically have the equation, the standard form for our ellipse. So that's what they're going to look at. All right. So we've gotten the center point, and then we have the major and the minor axis, and we plug that into our values here, and that becomes our equation for an ellipse. Center, a squared, b squared, always equal to 1. And then there's our final response. All right. So another one where we have values where I have the vertices, okay, and then the focal points. And so we need to know whether our vertices lie along the major axis, the minor axis, the way that this is given. Again, if we plot our points, so if I was to take my expression, so I have a, I have my coordinate plane, and I go 3, -4 as a vertice, and then at 3, 6, 1, 2, 3, 4, 5, 6. That's the other one. I can see that that distance there, So to go from -4 to 6 is a distance of 10, which means halfway in the middle is going to be where my center is. I know that my focal points, right, are going to be 3 and 4. So over 3 and up 4, 1, 2, 3, 4 is right there. And then down 3, -2 is right there. So this is my major axis, right? I know that my center is going to be in the middle. So if I do -4 plus 10, that's going to be up at 1. That's going to become my center point, H and K. And then using the distance of to the focal points is going to give me a value of C. And I know that this 10, half of that is going to be A. So if I know A and I can figure out C, I can figure out B as well. And once I have A and B in the center points, what I'm able to do is put it in the standard form for my ellipse. So that's what it's going to do to work through this. So let's look at this. The major axis is 2A, so it's going to take half of that, which is going to be 5, which is what we found. It's then going to figure out what C is. All right, so 2C is that distance. We know from find B. So this is what we talked about. We have C, we have A, we figure out what B is, and then once we have B and A, we can get the equation. So B is going to become 4. And then given our center point, so 1 and 3, right? A and B A squared and B squared that we found always equal to 1. That is going to be our expression. Our equation for that ellipse. All right, you need to do the same thing. All right, so be careful with the term co-vertices in terms of what that's giving you. It's giving you a major axis length, so that relates to A, and then you need to use those co-vertices to figure out a value of B, and then where those are going to cross is going to be your center point. So go ahead and solve that problem, and then start the video again. All right, our last kind of topic here with looking at this is our eccentricity or eccentricity. Either one is fine for this class. And what we can see is that it's the value of C over A. All right, and that this difference, if we have two focal points that are really close to each other. So what we're talking about is we have an ellipse. It looks like this, where there's my center. And then I have a value of A, and then I have a focal point and a value of C. All right. And what we're going to look at is how close to 1 or 0 is this going to be. So what I could see is that if A was really stretched out, so if I have a long stretched out value, what is that going to do to my eccentricity versus a more rounded shape like a circle? All right, so we're going to look at how those values go together to determine what kind of the general shape is. All right, so we're going to take a look at this eccentricity piece in our kind of lifetime animations using Desmos. So what this will do for us is it'll look at kind of what does that shape do as we look at those values. So we can see that we have our two focal points. All right, so our two focal points are right there. And as we make A bigger, so as I make that more stretched out, what we can see is that eccentricity is getting larger and closer to 1. It can never be 1, right? Because C always has to be less than A. But as C gets much, much, much closer, that ratio comes closer and closer to 1. So a larger or eccentricity value closer to 1 is going to be more stretched out. If we go the other way, we make it more rounded, we're going to see that those values of C, so from that center point to the focus, is getting smaller, and then A is getting larger. And so as we keep that moving, we see we get that more rounded shape, right? Or closer to a circle. So a smaller eccentricity is going to be more rounded. A larger value closer to 1 is going to be more stretched out. So we can calculate that. Relatively straightforward. So I can have a standard equation. Okay, if I've been given, I know that this is my A squared value, B squared value. I can figure out C, and then I just take my ratio to figure out what my eccentricity is. So I figure out C, and then I have it simplified, and then from there I just calculate C over A, and that gives me my value of 0.66. That's it. All right. So that is the eccentricity of that ellipse. All right. And this is just going through that again. All right, so you are going to need to figure out the eccentricity of this ellipse. You're going to need to first off put it in standard form so you can figure out A and B. And then once you have A and B, you calculate C, and then you take that ratio to determine the eccentricity of your ellipse. All right. Last topic is equations of circles. The circle is a special sort of ellipse where basically our major and our minor axis are the same as we go through this. So it's perfectly round. We don't have any kind of oblong shape to it. So we can see that they have this as r squared. You've seen that before from previous classes. What we can do is if we were to divide everything by r squared, r squared, r squared, we notice that that would be a squared, that would be b squared, and they're just the same, right? So if you look at something that has a major axis that is the same as the minor axis, you get a circle. That's really all we're looking at. So the same properties that you looked at for your values are going to be, for ellipses, are going to work for a circle, right? So if you needed to determine the type of conic, right, you need to figure out what it's going to be by putting it in standard form. You can note right off the bat, it's not going to be a parabola because you have two squared terms. So same thing we've done before, you're going to collect your x terms and your y terms. You're going to complete the square, put it in standard form, and then try to figure out, is it an ellipse where a and b are different, a circle where a is equal to b, or not particular in this case, where there'd be a parabola if one of those was not a squared term. So it's going to take the original equation, bring the terms together, complete the square. We're going to get that we have these values. What we notice, right, is that these terms are not the same, right? A is not equal to B, so it can't be a circle, which means that it's going to be an ellipse, all right, where we can see the center point and we can see the major and the minor axis. And if we needed to calculate the foci, we'd be able to do that. All right, so your last guided practice here is you need to take this equation and figure out, again, is it an ellipse, is it a circle, by grouping like terms and completing the square. All right, good luck.